Hi students, I'm back with lesson 5.5, part 3, which is really, let's just practice. Let's just get our heads wrapped around this. We had a lot of learning in the last couple lessons, so I just want to make sure that you have the opportunity just to see some more examples and practice referencing the different ideas. So to begin, we're just going to start with recognizing how many triangles do you think are formed in each of these different scenarios. So I encourage you to pause the video as always and do your studying on your own. I do have our scenarios over here, but I just want to make sure that you are able to make those connections on your own. So for some of you, it's going to be about drawing out the triangle. Again, I do typically draw out a quick triangle. It doesn't take that long to do. I always put my angle in that bottom left-hand corner, and then I put in the other information. Now, anytime this side is larger than the side adjacent to your given angle, I really do lean towards it being a one triangle scenario because it can't be two. Anytime this side is longer, it cannot be two. So I do want to make sure though that I check the height. And so the height of this is going to be 15 times the sine of 82 degrees. And so in this case, the height of this particular triangle was 14.85. So therefore it's smaller than this, and I can now confirm that this is a one triangle scenario. Awesome. Let's go on to the next one. So sketching out a quick triangle, it doesn't have to be perfect. Putting my angle in that bottom corner, the side given in this case is 24 and the adjacent side is 28. This lends itself towards potentially being a two triangle scenario, but again, we should always just double check what's happening. So I'm going to go ahead and say, all right, H equals 28 times the sine of 72. Let's just go ahead and type that in, and I just want to help us see this. So it's really not that long to type this in. Sine of 72 degrees, and I got 26.62. Well, that makes me kind of scratch my head a little bit because 26.62 or 63, if we round to the nearest hundredth, makes this height too high. The 24 will not be long enough. Therefore, it's not actually a two triangle scenario. It is a zero triangle possible. The height of that triangle is longer than the other side, and therefore it cannot work. All right, we've got one more of these to practice. And in this one, again, I find it very helpful to sketch that triangle. We've got 30 degrees. Again, no matter what letter, no matter what angle is given first, put that angle in that bottom corner. Side C is 9, and then the adjacent is 18. So right off the bat, I go, all right, this is smaller. It could be a two triangle scenario. Let's go ahead and test it out. So H is equal to 18 times the sine of 30 degrees. And when I type that in, I get 9. Well, when the height is the same as the side across from the angle, it produces one triangle. So there you have it. Quick little practice on the 0, 1, or 2 triangle scenarios. Moving on, I've just got a couple more examples for us. So I have 3 more examples actually. I don't want to tell you any sort of fibs. So in this problem, we're just going to be finding angle B, and they gave us the information that is listed right here. So I'm going to go ahead, grab my line tool because my sketch triangles are just not quite nice enough for you. And so I'm going to go ahead and sketch this triangle out. It's not going to be perfect. It's actually not drawn very well to scale at all, because angle A is 105 degrees, and this is definitely not an obtuse angle, but that's okay. Side A is 35 feet, and then the adjacent or side B is 8 feet, which makes this angle B, C, and little c. Now notice in this problem, I'm just asking for angle B. We're starting to get the process down, so we probably don't need as much of that. Now I do notice the side opposite my angle is very large, and it's much larger than this one. So it's definitely not going to be a two triangle scenario, but we should just check to say, well, what is the height? So the height here is found by taking 8 times sine of 105 degrees. And when I did this, I got 7.72. So absolutely, this is a one triangle scenario, as the height is smaller than the side opposite the angle. So now we can go ahead and find angle B by setting up our proportion. Remember that when you're doing this, you really want to find that angle across from a side that is given. That's the only time the law of sines can work for us. And so that becomes my core proportion I set up. So sine of 105 degrees over 35 equals sine of angle B over side B. Multiplying by the 8 is the first step. And then to get rid of that sine, we're going to do sine inverse of both sides. And we can go to the calculator and type in that information. Again, I just feel like this is the one calculation that a lot of students struggle with. So I'm going to go into my calculator and demonstrate that just one more time for us. So we have second sine, and then we have 8 times regular sine of 105 divided by 35. And closing the parentheses each time, I like to just double check that. I get that angle B is 12.755, so I'm going to round that to 13 degrees. So 13 degrees, probably our smallest angle. All right, there you have it. We found angle B. Let's go ahead and move on to the next one. All right, so in this problem, I've pre-sketched a triangle. Must be on top of it today. And we have angle A is given, that's 35 degrees. Side A is 7. And then side C is 8, which means this is angle C, and this is angle B and little b. All right, so again, side, angle. You can definitely tell I'm having us really work a lot on recognizing those different scenarios. In this problem, it does say to solve for angle C only. So it's not asking us to solve the whole triangle. It just wants us to find that angle C. Now, even if it says find angle C, we do always want to double check that it isn't a two triangle scenario. So to do that, because this side is smaller, it could swing and land early and create two triangles. So let's find the height, which is found by taking 8 times sine of 35 degrees. And when I do that, I've got 4.59, which makes this two triangles. So when I write my answer, I'm going to have C1 and C2. And so this will be like my C1, the regular one. And then C2, I'll show you how to do that solving as well. So let's start with C1. Our angle and side that are across from each other are here. Oops, let's just grab the big highlighter. There we go. And I get sine of 35 degrees over 7 equals sine of C sub 1, that's our first angle C of our two triangles, over 8. Multiplying by 8, just kind of keeping that roll going. And then doing sine inverse. Grab that calculator and you can go ahead and type that in. When you do type that in, you should get, let me check my notes here. I got 41 degrees. And again, I'm rounding to the nearest whole degree. So C sub 1 is 41 degrees. Now, recall, we said that this side is going to swing over and create, oops, let me undo that for a second. Let's grab this line instead. That line is going to swing over and basically create an isosceles triangle. And that isosceles triangle that is created creates our second C sub 2 angle, which is actually this inside angle right here. And so because we know that this C1 is 41 degrees, that makes an isosceles triangle that we don't care about. And we can find now C sub 2 by taking 180 minus C1. And that is going to give us our remaining value, or 139 degrees in this case. So C1 found, C2 found. Anytime it is an ambiguous case where you get that two triangle scenario, be sure to find both angles. All right, moving on. I have one last example, and the last example I have for us today is an application. So just kind of connecting it all the way back. So in this particular problem, we are looking at a situation where we have two ranger stations that are 10 miles apart from each other. So there's our grassland area, and it says that station B is due east of station A. So we'll go ahead and state that this is station A and this is station B. I did put in a compass here for us so that we would have that for recognizing. And it says that station A spots a fire that is 32 degrees east of north. So 32 degrees east of north means if you drew a line straight up from here, it would be 32 degrees this way. All right. And it says that Fire Station B, or Ranger Rick at Station B, sees the same fire. Again, they from due north was west of north, and that was 48 degrees. And looking at our picture here, we can see that the fire, make a little flamey fire thing here, this would be our fire. So we did create a triangle, and we did know that these stations were placed 10 miles from each other. And this forms a right angle here. Remember that the compass has our right angle situation. So that makes this bottom angle right here 58 degrees. And this angle over here, 42 degrees. Now, this is a great situation because it's an angle side angle. This is not an ambiguous case. We actually can just jump right in. We've done a lot of ambiguous case, but we can find this third angle by doing 180 minus 58 minus 42, and we get 80 degrees. So again, that angle was found by doing your 180 minus 58 minus 42. Now we can set up our proportion. We have our angle across from our side, and we want to find both of these values. So if I wanted to find the distance that is drawn in blue, so this line right here, I would have to take sine of 80 degrees divided by 10, and that's going to equal sine of 58 degrees divided by whatever we get for that line, which is actually little a if you want to think about it with our properly labeled triangles. All right, and going through and doing our multiplying and solving, we get a times sine of 80 equals 10 times sine of 58, and dividing by sine of 80 on both sides, a equals 8.61. So Ranger B is 8.61 miles from the fire. We'll go ahead and solve on the other side as well, because they did ask us to find the distance each station was. And to do this, we again would set up sine of 80 over 10 equals sine of, in this case, 42 over B, and doing our solving. B sine of 80 equals 10 sine of 42, and then dividing by sine of 80, we end up getting B equaling 6.79 miles. So if they had to send somebody quickly, they probably would send the Ranger at station A because they were closer to the fire, and they would be the first Ranger to be able to report onto site, most likely. All right, there you have it. We've studied our law of sines. We're going to continue to use law of sines in the upcoming lessons, but hopefully you're understanding that ambiguous case a little bit better, and just keep practicing. Have a great day.